Right now, somewhere past the edge of the solar system, a machine older than most of our parents is sending Earth a signal we still cannot fully explain. It takes almost a full day to arrive, not because it is slow, but because it is unimaginably far away. Over 24 billion kilometers separate that machine from the dish that finally catches its whisper. By the time the signal reaches us, it has already spent nearly 23 hours alone, crossing a darkness that has no roads, no landmarks, and almost nothing to interrupt it. That machine is Voyager 1, and it was never supposed to make it this far. It was built in the 1970s, carrying a computer weaker than the one inside a modern microwave, powered by a radioactive battery that has been quietly dying for close to 50 years. It was designed to survive 5 years of spaceflight. Instead, it has survived for nearly 50, and in the process, it has stumbled onto something in deep space that scientists still cannot agree on. Voyager 1 launched in September of 1977, and on paper, the mission sounded almost modest. Fly past Jupiter, fly past Saturn, take some photographs, send them home, and quietly fade into the history books as one more successful planetary probe. It did exactly that, and then it kept going anyway. By 1979, it was staring directly into the storms of Jupiter, a planet so large and so violent that it rewrote what scientists thought they knew about gas giants. By 1980, it threaded its way past Saturn and its astonishing system of rings and moons, gathering data that would occupy researchers for decades. Each planet gave the spacecraft a gravitational slingshot, a free boost of speed that flung it further outward into the dark, faster and farther than any human object had ever traveled before. Somewhere in that long outward journey, Voyager 1 stopped being just another planetary probe and became something else entirely. It became the first machine built by human hands to leave the immediate neighborhood of our star. Along the way, Voyager 1 was never traveling alone. Its twin, Voyager 2, launched just weeks earlier on a slightly different trajectory, one that would eventually take it past Uranus and Neptune as well, giving humanity its only close look at the two outermost planets for what may end up being a very long time. But it was Voyager 1 that took the more direct route outward, sacrificing a tour of the ice giants in exchange for a faster path toward the edge of everything familiar. That trade-off is part of why Voyager 1, and not its twin, would eventually become the first human-made object to leave the solar system in any meaningful sense. Every year that passed after the Saturn flyby, Voyager 1 drifted further into territory with no precedent, no prior data, and no way to know in advance what it might encounter. Engineers on the ground kept adjusting its instruments, rationing its dwindling power, and recalibrating its systems for a mission that had already outlived every original projection by decades. In 2012, Voyager 1 crossed a boundary that most people never think about, a line called the heliopause. This is not where the planets end. It is where the sun's influence ends. Beyond that line, the solar wind can no longer reach. Beyond that line, a spacecraft is no longer inside our solar system in any meaningful sense. It is drifting through the space between stars, a region of the galaxy that no human instrument had ever measured directly from the inside. Scientists had modeled this boundary for years using indirect data, telescopes, theoretical predictions, and educated guesses based on how other stars appeared to interact with the interstellar medium around them. None of that indirect modeling fully prepared anyone for what an actual spacecraft would find once it physically crossed that line. And that is where the story stops being simple. For decades, scientists pictured interstellar space as close to silent. Thin, cold, mostly empty, and largely uniform, a calm void stretching between one solar system and the next. Since 2017, the plasma wave instrument on board Voyager 1 has been detecting something that does not fit that picture at all. It is a faint, narrow, and remarkably persistent hum, not a sudden burst, not an equipment glitch, not a single strange reading that can be waved away as noise. It is a continuous tone, present year after year, coming from the plasma, drifting silently between the stars. Nobody predicted this. The models that scientists relied on for decades said this region should be smooth, calm, and largely featureless. Instead, Voyager 1 found density fluctuations, turbulence, and structure, as if the so-called empty space between stars actually has a pulse running through it. But researchers still do not fully agree on what is causing the sound. One theory suggests it comes from natural vibrations inside the plasma itself, oscillations triggered by the surrounding environment. Another theory suggests it comes from the random motion of electrons, a kind of background static that happens to reveal the true density of the interstellar medium. Both explanations are scientifically reasonable. Neither one fully explains why the hum has continued for years without stopping, without fading, and without any clear end in sight. What makes this discovery so valuable is not just that it exists, but that it gives scientists a completely new way to study interstellar space. Before Voyager 1 detected this continuous tone, researchers largely had to wait for rare solar eruptions to send shockwaves out into interstellar space, disturbances that would briefly light up the plasma and allow for a rough measurement of its density. Those events were unpredictable and infrequent, leaving long gaps where nobody had any real data at all. The steady hum changes that entirely. It gives scientists something closer to a continuous, ongoing measurement, a way of tracking how dense the plasma between the stars actually is over time, without needing to wait for a rare cosmic event to illuminate it. In effect, Voyager 1 turned itself into a permanent listening post in a region of the galaxy that had never had one before, and the implications of that shift are still being worked out by researchers who never expected to have this kind of continuous window into interstellar conditions. Long before Voyager 1 ever detected that hum, it had to cross something even stranger, a boundary that scientists have half-jokingly nicknamed a wall of fire. For a long time, the assumption was that the outer edge of the solar system would be a gentle handoff, the sun's wind gradually weakening while interstellar space gradually took over, a slow and undramatic transition. That is not what Voyager 1 found. Instead, it crossed a violently energetic boundary where charged particles were colliding and compressing at temperatures reaching tens of thousands of degrees. This is not happening inside a star. It is not happening near the surface of the sun. It is happening at the far edge of our solar system, in a region most people imagine as cold, dark, and essentially empty. There are no flames in the ordinary sense, no oxygen, nothing burning in the way we usually picture fire, but the energy involved is completely real, and it matters far more than it might sound. This turbulent boundary is part of the heliosphere, the enormous bubble that shields our entire solar system, including Earth, from a significant portion of the galaxy's raw cosmic radiation. If the outer edge of that bubble is more chaotic, more energetic, and less stable than scientists once assumed, then the shield protecting our planet may be more complicated, more variable, and more fragile than anyone previously understood. Voyager 1 also detected something odd happening with the magnetic fields at this boundary. Instead of staying neatly separated, the sun's magnetic field and the magnetic field of interstellar space appeared to be interacting, reconnecting, and releasing energy in ways that challenged existing models of how the heliosphere actually works. None of this was visible from Earth before Voyager 1 physically crossed the boundary. Telescopes can observe the general shape of other stars' heliospheres from a distance, comparing brightness and structure, but there is no substitute for a spacecraft actually passing through the region and recording what the particles, the temperature, and the magnetic fields are doing in real time. That is precisely what makes Voyager 1's data so difficult to replace. It is not a theoretical model built from distant observation. It is a direct, physical measurement taken from inside the exact environment scientists are trying to understand. There is no other instrument currently capable of repeating that measurement anywhere close to the same location. Then in late 2023, the mission nearly ended in silence, though not the kind of silence anyone expected. Voyager 1 began transmitting nonsense. It was not going quiet. It was still talking, still sending signals across billions of kilometers, but the data arriving on Earth was corrupted and unreadable, as if the most distant machine in human history had suddenly forgotten how to speak in a language anyone could understand. For months, engineers faced one of the most difficult repair problems ever attempted. The spacecraft sat more than 24 billion kilometers away, far beyond the reach of any physical repair crew, with no way to swap a part, no way to reboot it in any casual sense. Every single command sent from Earth took nearly 23 hours just to arrive, and every response took almost another full day to travel back. A single diagnostic test could consume nearly 2 days of waiting, and there was no guarantee that any given test would even produce useful information. Making matters worse, the hardware itself was a relic, a computer system designed in the 1970s, carrying only a tiny fraction of the memory found in modern devices, and worn down by nearly 50 years of exposure to cosmic radiation in the harshest environment humans have ever sent a machine into. Eventually, after months of painstaking analysis, engineers traced the problem to a single degraded memory chip, a component smaller than a fingernail that had quietly corrupted part of the software Voyager 1 used to package its data before transmission. That tiny failure came remarkably close to ending one of the greatest scientific missions ever attempted. But the team refused to give up. They carefully identified the damaged section of memory, broke the affected code into smaller pieces, and relocated those pieces into other parts of the spacecraft's limited memory, effectively rewriting the internal logic of a dying, decades-old machine from billions of kilometers away, using nothing but patience, old documentation, and commands that took nearly a full day just to arrive. In 2024, against long odds, Voyager 1 came back online. It began sending readable data again, and among the very first things it returned were more measurements of that same unexplained hum drifting through interstellar space. It is worth sitting with how close this came to going the other way. Voyager 1 is not a spacecraft that can be visited, serviced, or upgraded in orbit the way some modern satellites can. Once a fault like this appears, the only tools available are whatever remains functional inside the spacecraft itself and whatever expertise remains among engineers on Earth many of whom were not even born when Voyager 1 first launched. Entire careers have now been built around understanding a computer architecture that most of the modern technology industry abandoned decades ago, simply because no other spacecraft in human history has needed that expertise kept alive for this long. Losing that memory chip could easily have meant losing the mission entirely, cutting off the only continuous data stream humanity has ever had from inside interstellar space, permanently and without warning. This is the part of the story that should concern people far more than any single strange reading. Voyager 1 runs on a power source that has been steadily decaying since the moment it launched. At the start of the mission, its generators produced several hundred watts of electricity. Today, that output has fallen to less than half of what it once was, and it continues to decline with every year that passes. Mission engineers have already been forced to shut down instrument after instrument, one at a time, simply to keep the spacecraft's transmitter alive long enough to keep talking to Earth. At some point within the next decade, possibly sooner, the available power will drop below the threshold needed to communicate at all. When that moment arrives, the signal will not fade away slowly over weeks or months. It will simply stop. There's currently no spacecraft anywhere near ready to reach that same region of interstellar space anytime soon, which means that whatever Voyager 1 is still detecting out there, the persistent hum, the turbulent boundary, the strange behavior of distant magnetic fields, humanity may go decades, or possibly much longer, without another instrument stationed in that exact part of the galaxy to continue watching and listening. So what has Voyager 1 actually found, after nearly 50 years of traveling farther than any human-made object in history? It is not a monster hiding in the dark, and it is not some dramatic signal from an alien civilization. It is something arguably stranger than either of those possibilities. Proof that the vast space between the stars, the region we spent decades assuming was silent, cold, and essentially empty, is not silent at all and is not empty at all. It has structure. It has motion. It has, in some strange and difficult to define sense, a voice, faint, thin, and barely audible across a gap of 24 billion kilometers of open space. And at this exact moment in human history, there is only one machine anywhere close enough to hear it. That machine is nearly 50 years old, running on a power supply that grows weaker every single year, carrying instruments that were never expected to survive this long in the first place. Nobody knows exactly how many more signals it has left to send, or how many more strange readings it might still capture before its power finally runs out for good. Every faint transmission that reaches Earth from this point forward is essentially irreplaceable, a fragment of information about a region of space that humanity may not be able to study directly again for a very long time. Whatever Voyager 1 still has left to tell us about the plasma between the stars, about the violent boundary at the edge of our solar system, about the hidden structure of the space that surrounds our entire cosmic neighborhood, we are running out of time to listen. The window is still open right now, but it will not stay open forever, and once it closes, the silence that follows may last far longer than anyone currently working on this mission will ever get to see resolved.